Okay, so part D, the last part of this, the question is asking, evaluate that integral. Okay, so it's going to be x times that integral. So from 0 to 5. So if I want to integrate that, so if this is part D, I want to evaluate the area under that graph of x square root 25 minus x squared dx. Well, to do this, this is not a standard integral, so I have to look at my possible alternative methods, and my alternative method is essentially substitution. So I'm going to let the inside u be 25 minus x squared, and I'm going to check to see that the outside derivative du is going to account for that outside function. Yeah, there it is. There's my outside. Okay, and there's my inside function there. Okay, so this should work. I'm just going to rearrange my outside a little bit because I have x dx. So I'm going to just rearrange it to du over 2 just so I can keep track of that negative 2 a little bit easier. And then I'm going to substitute. So I'm going to do my substitution. So from 0 to 5. Now I cannot write it like this, although when we put it back to x's, it's going to be fine. But right now, since we changed the variable, we have to make sure that we state the variable of our bounds is x. Okay, and so when I write my integral, then it becomes the negative 1/2 du, and then I'm going to end up with the square root function, and inside the square root I have my u function. So it looks like this. So this is perfectly fine. This is consistent. Okay. Now, if I did not put x equals 0 to x equals 5, and I just put 0 to 5, that implies that I'm integrating u values from 0 to 5, which is not true. I'm integrating x values from 0 to 5. Now, it is possible to actually calculate the u values of my bounds by plugging in my x bounds into this equation. That would be okay, and then I can just leave it as 0, whatever it would be. I think it would be 25 to 0 or something like that. Okay, but we're going to change it back to x's, so I'm going to make sure that I keep track of the variables of integration and the variables of my bounds. If they're different, if they're inconsistent, we actually have to make sure that we're clear on what the variables of our bounds are. So continuing on then, I'm going to integrate this. So I get negative 1/2. This becomes u to the power 3 over 2, and then 3 over 2. My bounds are x equals 0 to x equals 5. I want to rearrange this a little bit. Okay, so I'm going to end up, the 2's cancel out here, so I'm going to end up with negative 1/3. Is that right? So I'm going to times by the reciprocal, yeah, and I'm going to have u to the 3 over 2. My bounds are x equals 0 to x equals 5. Okay, I'm going to switch back to x's. So negative 1/3, 3 over 2, and I'm going to switch back to x's. Instead of u, I'm going to use 25 minus x squared. And now I can just leave it as 0 to 5 because my bounds of integration match my variable in here. So the last step is just to plug it in. I'm going to end up with negative 1/3. Plug in 5, I get 0 to the 3 over 2 minus minus. Plug in 0, that's 25 to the power 3 over 2. Okay, so this is going to be, I'm going to square root 25, cube it, so I get 125. The negatives cancel out, so I get 125 over 3 units squared. Okay, if I'm actually calculating area. Okay, so there it is. There's the integral. I'm just going to show off to the side here. Okay, so that's done. This is an answer to the problem. I'm just going to show off to the side here. I think I mentioned that I could have left this as the bounds, but I could have changed my x bounds into u bounds by plugging it into here, because this equation changes x's to u's. So if I plug 0 into here, the 0 bound becomes u's 25. The upper bound x, if I plug it into here, the u bound becomes 0. Okay, and then my integral looks like this, u du. Okay, and then when I integrate, I'm going to get 1/2 u to the 3 over 2 from 25 to 0. And I can actually evaluate this integral. Is that right? Oops, I've got to divide by 3 over 2. And then I get negative 1/3 u to the 3 over 2 from 25 to 0. And I can just plug that into my integral. Okay, so I get 0 minus 25 to the 3 over 2. Okay, that ends up being this exact same thing. I'm going to square root, cube it. The negatives cancel out, and I get 125 over 3. Okay, so whether I do it with u's, my bounds as u's, or my bounds as x, I still get the same answer. But you just have to be careful. If I don't change this to x equals like this, it's implying that I'm integrating along with bounds of u, variable u. Okay, and just quickly sketching this graph, I suspect this graph is going to look like this. You're going to have negative goes through 0, and then positive, something that looks like that. Okay, because we have to have a 0 here, we have our n bounds, and we know that it's going to be negative y coordinates here, positive y coordinates there, so we're going to have a graph that looks something like that. Okay, so then the area under here is what we calculated. It's going to be, that area was 125 over 3.